Okay, now I will explain how the whole mass flow rate system is sort of derived. So effectively what happens is you have two cases. You have a dry case here and you have a wet case here. The dry case is when the valve at the bottom of the weighing tank is open. Okay, so there's water flowing through the tank, and there is some kind of gathered in the tank. And as you can see, in that case, it is resting on the bottom pin. You see these two little dots here, they represent the pin, so it's resting on the bottom pin in the dry case. In the wet case, that's when it just tips the scale and is up on the top pin. Okay, so effectively that water that is gathered in there comes to be enough to be greater than the moment on the other side of the pivot with the mass like I showed you in the previous video. So effectively, we'll start solving for these two cases because we'll effectively need to find out what the mass of the bucket and small amount of contained water are present in the dry case in order to solve for the mass of the gathered water in the wet case. So starting with the dry, we're solving for the dry mass, okay? So effectively, we have sum of moments. Here we have a static equation. So we have, at point A, we have our dry mass going down. So that's the bucket with a little bit of water that's flowing through it. You have point B, which is your pivot. You have point C, which at this point is giving a reaction of 9.25 kilograms. I took it upon myself to grab a spring scale, and I found that the reaction force is about 9.25 kilograms. So effectively 9.25 times 24 equals dry mass times 8, okay? And 24 and 8 come from the distances from point A to the pivot. So point A to the pivot is 8 inches, okay? And then from point C to the pivot is 24 inches. So effectively, if you put dry mass by itself, so effectively dry mass is 9.25 times 24 over 8, or 9.25 times 3. Our dry mass is 27.75 kilograms. Okay, so next step would be to find the mass of the gathered water, okay, after it's tipped up the mass. So the mass at the other end of the scale is 13.6 kilograms. I threw that on a scale and it spat out 13.6. Easy way to find that. So effectively, we have to say our wet mass times 8 is 13.6 kilograms times 24. So sum of moments again at play there. So effectively, you have your mass of the gathered water plus your dry mass, which we solved for before, which is 27.75 kilograms. That quantity times 8 equals 13.6 kilograms times 24. So we rearrange things. So delta M water, so the mass of the gathered water, is equal to 13.6 kilograms times 24 inches minus 27.75 kilograms times 8 inches, all over 8 inches, okay? So inches will end up canceling out, but what you end up getting is a changing mass of 13.05 kilograms. So from there, you have your delta M. This is going to be the same delta M for all flow rates, okay? But again, your time change will be different obviously for different flow rates. So effectively, the way you'll find flow rate is this delta M quantity, which is 13.05, divided by whatever time is given to you in the data that I'm going to send out.